Okay, so last week was our basic introduction to Python, right? So for today, we're going to focus on, let's see. Mm, so Zoom isn't actually capturing properly the background. Hmm, okay. Hang on for just a moment for some technical difficulties. The background isn't. Oh, that's why. Okay. All right. There we go. So for this session, we're going to be discussing about loops and selection statements. And if we still have time, we're going to go towards the next PowerPoint, which is about functions in general. So the next three PowerPoints are about functions in general, but each PowerPoint is focused on a specific topic. Okay. All right. So, all right. So when we, let's see. Loops, right? So we were able to start with for loop before. So for loops, basic form for loop, range function. Yeah, I guess we can start here. So this is the augmented assignment. Yes, we have it before. All right. So if you guys remember, the for loop is one of the things that we will use if we want to iterate over specific sequences inside of Python, right? This time we're going to discuss about augmented assignment. Okay. Now, it may look a bit weird, but this is actually quite simple. So for example, this is our basic assignment, right? Assignment operator when you want to um, assign a certain value to a variable. So for example, a is equal to 17, s is equals to high, a string high. In this case, there is a operation in front of it before the equal sign. So for example, the plus equal, right? Basically, this is equivalent to a is equals to a plus 3, right? And depending on the operator at the beginning, it will mean similar to what you see on the right, okay? So if it's minus, a is equals to a minus 3. If it's multiply, it should be multiply, right? So depending on the operator, it is what um, Python should um, do first before assigning it to the variable. So if it's to divide, it should divide a by 3 before assigning it to the variable a. All right. Now you might be thinking, what is the main difference between them? Okay. Like, what is the advantage of using this one, augmented assignment, over the one on the right? Okay. Now, its advantage is more pronounced if we're talking about this during the 90s, right? The early days of programming, where um, we want to make use of every bit of memory and processing power that we can get, right? So that nothing goes to waste, right? These days we have a lot of extra, and most users can't actually use everything that they have currently to uh, do some applications with, or just use the device basically. So we can't even use the whole thing anymore, the whole memory, the whole processor thing, because the technology is quite advanced already. Okay. Now, the advantage is because on the right here, you have to assign a temporary variable, right, to take hold of what a plus 3 is before assigning it to a, right? That's how computers understand when they read this one, right? They have to um, create a temporary variable that holds the current value of a plus 3 before assigning it to a. All right. In this case, the one on the left, we're basically telling uh, the computer, right? Python Assembly Computer to look for the location of variable a in memory. Okay. And then I want you to add 3 to that. Okay. Whatever value is in there, I want you to add 3 to that value. All right. So that's basically it. It's if you think about it, it's one less step. Okay. And it might not mean much these days, right? Oh, because of how fast things are, how big our our memories are. Okay. But in the past where uh it's very scarce, the resource is very scarce, uh it has a very big advantage before. So that's basically it. So if you were to ask me which one do I prefer, this is actually better, the one on the right, compared to the one on the left, because it's easier to understand this one, even though it's less efficient. Again, it doesn't really matter these days because of how fast things are. Okay. Next is loop errors. So off by one error. So this is basically just an explanation of the range function, because when you think about the range function, right? The output, if you think about the output, it starts from 1 and then ends in 3. Okay. So 1, 2, and 3. It doesn't include 4. Now, you might be thinking that um, it's probably a mistake by the developer, but it's actually not. It's actually designed that way because of how arrays work in computers. So arrays always starts at the number 0, which we'll discuss soon. Okay, so that's primarily one of the reasons why it's always off by 1. The last number is always not included. Um, Basically, it's like a way to avoid errors when you miscount something. Like um usually when you count how many items there are on an item, you say 1, 2, 3, and 4. So you're right, 4 here, right? Um and that's basically correct immediately, but you don't want to include the number 4 or something like that. So it's basically avoiding off by one errors. They call it off by one errors. So it's not a syntax error, rather a um logic error. So it forces us to think in in a way that can represent arrays much more easier. Okay. Next is traversing the contents of a data sequence, all right? So from the keyword itself, data sequence, it is a sequence of data, no matter what kind of data it is, right? So for example, here, this is what we call an array. So whenever you see a open and close bracket, and then some values in between, whatever those values are, whatever data type they are part of the sequence. So in this case, it's just numbers. So 0, comma, 1, comma, 2. Okay, so each value is separated by a comma. So more on that soon. What I want you to focus on is that this is a sequence of data, all right? And each data, okay, is more like there's a specific order to them. Okay, so from left to right, this one comes after this one comes after that one, right? So it's just like a line, right? It's not something that you can just skip and go directly to number 10, right? Or something. So the main point here, okay, the main point here is that the for loop can be used to access those kinds of sequences, right? Because um, it can, like the one example that we did before with the string, right? So this is a sequence of characters, and it's gonna start from left to right. It won't immediately go to um, the third letter or the fourth letter, right? It has to go through one by one from left to right. Okay, it won't skip directly to um, the third letter unless you specifically wanted it to skip, right? But in a normal function of the for loop, it will not skip, okay, unless you actually control the start of the variable, okay? In this case, the for loop, the way that for loop works in Python is that they take away the starting point. Okay. In other languages, like for example, um, JavaScript or something, what they have, or C++ in that case. So what they have is something like this. So for, and then as you can see, they have the same format, right? So they have for, and then you start with a variable like I, for example, and then usually it's a comma, and then we start with the initial value of I, whether it's 0, and then, oh, no, wait. The first is the initialization. There we go. The second one is the condition, like I is less than 2, less than 12. And then the third one is the increment. So I plus 1, for example. And then the code that you have, okay? So this part here, all right, is basically removed in Python. They want it to always start at the beginning, okay? And it will end the moment that it finishes the whole sequence, okay? In languages like C++, you can specify where it will start in the sequence and where it will end in the sequence, okay? But at the same time, this is much more confusing, and um, it takes a bit longer, right, to create one for loop. Whereas in this case, in Python's case, they want it to be more uh, usable directly. So you just have to look for what you want inside of the iteration. Like for example, you have a code here that look for the string um gender, for example, or age. Okay, so it's gonna keep on looping on each value until it reaches the value of age, right? Or maybe it could be looking for a certain number. You can say look for the number equal to 10, or maybe numbers less than 10. If you were counting how many numbers in your sequence, right? Inside the sequence, how many numbers there are that are less than 10, for example. Okay. So in a way, this is actually much easier for us to do. And that's one of the reasons why Python is very popular with a lot of programmers. Okay. All right.
May I ask, sir, question?
Yeah.
Because I noticed the slides that we've been reading are they look like greater than, greater than, greater than. We should when we type those, we should omit it when we type, right, with these greater, greater than signs, correct? Because they look
Yes.
like in machine readable passport. They put greater, greater than in the bottom, so that's not part of the algorithm instruction, correct?
Yeah, that's not correct. No, that's not included in the code. This is usually used in the shell. So when this PowerPoint was created, the one that made this was creating it using the shell. All right. In this case, what we are using is Jupyter Notebook. What they were using, or he or she, was the shell. And in those things, let me just show it to you so that you guys can see for yourself. 64-bit. Yeah, I think it's this one. Okay. So let me switch screens right now. Okay. So this is what the shell looks like uh, currently. So this is a 2023 version, 64-bit version 3.12 of Python. Okay, now as you can see, there are the um, greater than symbols, right? Exactly like the one on the PowerPoint. Okay, now if I were to, where is it? Where is my screen? There you go. So if I were to, let's say, print something like print and then hello. Okay, exactly like what we do in Jupyter Notebook, right? As you can see, it also prints it below. So the output is at the lower part, okay? Exactly like what you see on the PowerPoint. So you can just ignore those greater than symbols, okay? Um, you just have to understand that you can code in a lot more environments other than Jupyter Notebook, right? There's an online one, there's Shell like this one, there is Visual Studio, and all of them looks different, but the way that we code is the same, right? So yeah, I hope that answers your question. Um, okay, let me go back to the PowerPoint. Let's see. All right. So this is actually much easier because it prints out, we can clearly identify the output from the input, and then it has a lot of color coding. Okay. So it's easier to understand the code here than the shell. Let's see. Where was I? Okay, so we learned how to use the range before. We're done with that. Negative. Did I have that example here earlier? Yeah, okay, we can do that one. So, range can also work in negative numbers, right? Like what you see here. So you can indicate the starting point as something bigger. So if you want it to work backwards, okay, so 100 and then 50, right? And then you want it to go backwards in steps of 2, so -2, right? It works exactly the same way, okay, as going forwards. So, in certain applications where you need the numbers that goes backwards, then you can do it like this, right? Okay, so it's just as simple as that. Let's see, text formatting. All right. So this is the part where we will format how it looks like here on the output. Okay. But take note, this is just for basic output, like from the print. Um, which is not really the kind of output that we will be doing in data science. Usually our outputs are in tables, in charts, right? It's not just basic numbers like this one. It's not really good to look at. Okay. But in cases where you have to output it like this, then we have a way to format it. All right. Um, Basically, what we need to understand is there's a certain part that it calls the field width. So this is a total number of data characters and additional spaces for a datum in a formatted string. Okay, so that's a mouthful. So basically, it looks like this one. Okay, this is your format string. This is the syntax in order to format your output. This is your format string, followed by the percentage sign, and then your data. All right, or where what your data is. Okay. This version contains format string, format operator, and a single data value, like I said before. So to format integers, you need to use the letter D, and S is for string, if I remember correctly. So you can search the other how to say this format strings for this one. So I don't we really have this one memorized because I don't use this one a lot. I'm just sharing this one in case some of you will use it. All right. The way that this works is something like this. Okay. So for example, we have a print statement here. All right. And it starts with percent minus 3D and then percent 12D. Why is the percent at the beginning? And then exponent. Oh, okay, yeah. So this is the format string. Okay, as you can see, it has quotes, right? So starting from here, okay, this is the format string. And then percent sign, this one, right? And then this is the datum, right? The datum is stored inside an open and close parentheses because you have two types of data that you want to format. Okay, one is the exponent. This is the first number here. The second one is the 10 to the power of exponent. This is what is described here. All right. Now, this is actually pretty simple if you think about it. So in your format string, you start with the percent symbol, right? Followed by how many spaces do you want for your data? Like, for example, the -3 here. So you want 3 spaces for your first data, the one on the left, 3 spaces. The negative sign there is just for alignment purposes. So negative is for left aligned. So if you take a look, it's aligned to the left. I don't think this is the correct output. I think it's the one on the next. Okay, so it doesn't show it. All right. We'll just print it out later. Okay, let me explain first. D is for it's explaining that it is an integer data. Next is for the second number, the one on the right here. So it's 12. So we are allotting 12 spaces there for that number, for that data. And then it is also a integer with the letter indicated the letter D here. All right. Next is the percent sign as indicated by this syntax. Next is on the datum. We have for the first number, we want it to be the exponent. In this case, it's from the for loop from range 7 to 11. And then on the second one, it's 10 to the power of exponent. So as you can see, it's performing an operation here. All right. Before it passes it to the print statement. Okay, so you can do that one. And then let's see. Prints it out here on the output with the available spaces. So let's try this one out actually. So it has the for loop, right? For temp in range. Let's try 5 and 10. Okay. And then we're gonna print what? So it used negative, right? Negative, let's say, okay, let's just follow this example. 3D, I know, percent, negative 3D, and then percent 12D, right? That's the one that it used. Percent. And then after that, it's the datum. So we have temp and then and then 10, no wait, 10 to the power of 10. Okay. Yeah, I think this is the one. There we go. So don't follow this example. I think it's because of it's in the PowerPoint. That's why it's not um properly aligned, but this is what the output should look like. All right. So we can't really see this one, right? That it has three spaces. So if we use a bigger number here, like let's say 200, and then, well, if that's the case, wait. Let's start first with the right. Okay. So if you count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, and then 12. 11 and then 12. So there are 12 character spaces here. And then there is an extra one, extra two that we haven't used, right? So on the left, how many it should have? It should have three. So one, two, three. All right. So exactly where we counted earlier. So that's how you count it out. So three on the left. Okay. There are three spaces here for this number, right? And there are 12 spaces for this number, right? So right now, the second number here has no negative sign, so automatically it is right aligned. If we were using bigger numbers here, like for example, 10 up to 20, right? Okay. Okay, there we go. So as you can see, the numbers are aligned to the left. Okay, this is because of the negative one. If we remove the negative number here, you'll see that they are aligned to the right. Okay, so we are aligning it to the left because it's very hard to read here. So as you can see, the space is now on the left side of the first number. Okay, so let's put the negative back. Um, so you might be wondering what happened here, right? So at this point, this is 12 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12 characters, okay, as indicated here, 12 characters. So on the next number, right, there are now 13 digits on that number. So what does it do? It goes back to its default mannerism where it will stay at the left aligned position and then put all the overflows to the right. So that's why it looks like it's going over to the right here. Okay, because it went over our allotted space. So that's what happens when it goes over to your allotted space. Okay. Again, if you align both of them to the left, this is what it would look like, right? Again, it's really hard to read. I guess it depends on what type of data you're handling. Okay. So usually, this is used on the decimal and integers. If you're using, mm, forgot the letter to use if it was float. I think it was F. Let's try it. Yeah, so it was F. So you have to look for a function that will round this one up, like the one that um I forgot who answered that last week. They were using the round function to make it two decimal places, right? So again, this number here is included, this dot is included in the number of characters available, okay? So if it's a floating point number, use F. If it's decimal, use D, okay? But so there are other ways of formatting strings. There is the, so just for context, there is the um string, right? So whatever your string is, so string, right? And then that format, there's this one. There's also, let's see. Well, the basic concatenation, you can use the basic concatenation to achieve similar results. But usually the one that I use is called the F string. Okay. And the F string is actually very simple to use. It's much simpler to use than this one. So in order to get the same effect as what we had here, right? Um, let's see. Okay. So the way that the F string works is that you have to start first with the letter F in the beginning and then followed by the string. Okay. Now, you just type in any regular characters here, like you're actually typing a string. But the difference is that if you want to include a variable or an operation inside of the string, you can do so by using an open and close curly brace, right? So let's try and follow that format. So at first, it wants to display the temp, right? And then there's a space. And then afterwards, it displays the number. Okay. Temp, wait, 10 to the power of 10. Right. So the only problem with this one is that it's not properly aligned, right? Um, so how do we fix this one? Well, let's see. So we can use some more advanced functions in this one, string functions to add some characters, right? So in other words, in order to replicate this one using the F string, we're gonna have to use an extra function inside here to make it have the same characters, okay? And then, of course, we're going to have to align it to the right as well. But, in any case, this is actually the faster and easier way compared to this one. Again, we won't be actually displaying outputs like this. Usually it's in charts, so you don't really see this one a lot in data science projects. This one is just for controlling your, let's see, the number of decimal places. So earlier, if this was float, right? So if this was three, so three characters and then dot and then two decimal places, if I'm correct. Yeah, there we go. So it's actually included already. So this is how you control the number of spaces. So if you take a look, there are one, two, three, four, five. So I guess it's better if you make this one six. There we go. So in that case, there is a space in between, and then we can actually read it much better this way, right? So you start with how many characters, including the dot, followed by the dot itself, and then the number after that is how many decimal places you want. So if you want one decimal place, you put one here, and then you run this program again, and there it is, so one. So that's how you use this format. Let's see. Selection statements, yeah. So it's finally time to go to selection statements. So these are the if and if else statements, basically the same as the for loop, um, where it we have to indicate it like this one, okay, in like this kind of format. The selection statements is actually based on a condition. Actually, the for loop is also based on a condition. The condition here is that um, it will not stop iterating over a sequence until the sequence is finished, all right? Until all of the values inside of the sequence is processed, right? Or iterated over. So in this case, it's just one condition. We're just basically asking one question. That's what it means. Um, before we actually have to use that one, we have to understand what Boolean data type is. So Boolean data type is there's just two values for that one. It's going to be either true or false. All right. Those are the only two values of a Boolean data type. Okay. Now, how do you achieve true or false values? So basically, you can achieve that one by comparison, okay, or comparing comparing things, right? Whatever those things are, numbers, strings, okay? So for example, if you are comparing something like numbers, so if you say is 5 less than 6, the answer is true, right? And if you run this one, it will display true, okay? The computer can understand that 5 is less than 6. If you were to say 7 is greater than, I don't know, 6, so which is false. Oh, wait, but this is true. Let's make it false. 10, right? As you can see, it also understands the greater than symbol. What about equality? So if I say, are they equal? Okay. As you can see, one equal is not correct. You need to use two equal signs to um, compare them, right? Is 7 equal to 10, which doesn't make sense, right? Of course, this will return false. But if I were to say, is 10 equals to 10, it will return 2. Is 10 equal to the string 10? This is false, right? Because they are of different data types. Is the string 10 equal to 10? True, because they both have the same values and they are both of the same data types, all right? So there are a lot of things that we can compare later on. But for now, let's just focus on these two things, strings and numbers, right? The important thing is that in order to achieve true and false values, you have to compare them, all right? There are special values available, like the number 0. Okay, so it doesn't actually detect. You need a special function in order for 0 to be treated as false. Okay, so it doesn't directly detect as false. How about null? Is null a value? No. Void. Okay, Python doesn't have void. Let's see, what else does Python have? Hmm, I forgot the other things. Let's see. So if we have equality, there should also be inequality, right? So if I'm correct, it's this one. Punctuation equals to 10. There you go. So is 10 not equal to 10? Of course, that's false because they are equal, right? Now you might be confused. Why would anyone use this one over an equality, right? Because there are certain cases where it's easier to check if if something is not equal compared to something that is not equal, right? Like, for example, if the condition is that uh, you're if the condition is you're looking for a certain number, right? So of course you're going to be using equality, right? Because you're looking for that exact number. But if you're looking for um, a range of numbers, for example, that is not equal to a specific value, right? Um, in which case, not equal is actually much easier to use because, like, you don't want the values 2, 5, 7, and 9, for example, to become to run your program, those values, okay? Instead of checking for 2, 5, 7, and 9, right? You can just um like use the not equal operator, okay, to wait, I think I got it in reverse. So if you have more, if you have less things to check that they are not equal to compared to things that are equal to something, right? Um, the one that requires less code is actually better. So in this case, it's the not equal sign. So For example, what if you need to look for 10 things, right, that are equal, right? Compared to look for three things that are not equal. So in this case, instead of typing out code that for those 10 things, right? And then you're going to be using the equal sign for this one. You could have just used the not equal sign to look for the things that it is not equal to, right? And then write code for that one, which is actually a lot less than looking for 10 things, right? So that's the logic behind this one. Other applications of this is when you're trying to prevent a function from working. For example, the print function, right? When it is executed, you want it to prevent other events from running it while it's not done. So something like that. So it's very confusing right now. Usually not equal to is not used a lot by beginners because it's a bit confusing at first, but as you keep on programming, it actually makes a lot more sense in certain applications. All right. So we also have the greater than and less than equal to, right? So everything in mathematics, we can also apply it here. Right. So this is what an if else looks like. This is the basic syntax. Okay. So it starts with an if, right? Followed by whatever the condition that you have. Okay. And then what comes after that? It's the colon, right? So colon, and then this is the code that you will um, code to run if condition is true, right? And then you put an else here, right? And then this is the code to run if condition is false, right? So this is the basic syntax of how an if condition works, all right? So let's try something simple. Let's say that um, I'm just going to use this one. Let's say that condition, all right? So as you can see, I'm just using a variable for this, but you can just put it directly here in the condition part. You don't have to create a variable. I'm just using a variable to separate them. Okay. So the condition here, so let's say the one that we had earlier. So 5 is greater than less than 6, right? Let's just make it simple. Let's make it print. Um, let's just make it appear true. And this one is false. All right, so as you can see, it will print out the value true. True, true condition, right? Just to separate it from the value true from the string of true. Okay, so true condition. If I were to change this one to greater than, okay, it will become a false condition. All right. So basically, when the condition becomes false, right, Python will skip the lines here and go directly to the else statement and then run the code here. Okay. If I were to add something else here outside, just to see the flow of the program, um, I'm here, right? So after checking the if condition, it goes to the else, runs the code, and then prints this one out. All right. So as you can see, it's just one straight flow. It's not the same with the for loop that it goes back until it finishes the whole sequence. Okay. Um, if this was true again, okay, and then I were to run it. So after it runs this code, okay, it will go directly to print. Okay, it will skip the else because this was reserved for when the condition is equals to false. All right. Now, this is the very essence of decision making in all programs. All right. Um, Basically, those things that you see that looks intelligent is actually just a bunch of if else um, programmed in a certain way that makes it look like it's actually smart, but it's just a bunch of if else. Okay. The more complicated your logic is, right, the more conditions that you need. Okay, but eventually, you're just limited to how many conditions you make, and that's how complex your program would be. Um, let's say, let's say that, let's say you're trying to check if the person is going to the left or right. Okay, so let's say it's left here, the value. Let's say this is value here. Okay, and we're gonna check if the value is equal to left. All right. So in this case, if I were to run this code, this is true. Okay. But if I were to make it right, all right, it's gonna say false. Okay. But you have to think about this. This logic is actually wrong, right? Because we're assuming that the user will only enter the values left and right. Okay, but you can enter things like center here, and it will also return false. You can enter any kind of character here, and it will still answer false. So the logic from the beginning that we said, if the user were to choose left and right, is already wrong because we are not how do I say this? We're not restraining the user from making those inputs. Like it should only make between those two inputs, left and right. So you're gonna have to limit the user, right, to what inputs are available. Okay. So if we change value here to be an input, right? Input. So remember, an input will convert it to a string. Um, Give me your input, right? So it's a bit more dynamic now if you think about it. So if I were to run left, true, right? If I were to run this one again, any other character, it will say false. Okay. Now, how do we differentiate when a user has entered right and any other characters? Okay. So in that case, we can use something called if else, right? So we can add something else here. If else, okay. Um, let's see if it's also included here, just to make sure. All right. If else, sorry. I'm using a different language. This is what happens if you're working with a lot of languages. It's elif for Python. If else is used in JavaScript, in C++. Right. So it gets a bit more confusing, but the logic is still the same. It just has a different syntax. elif is used in Python and it works like this. So in this case, we're trying to check if the user has entered right. So if it's not left, so it's gonna do another check. All right. So maybe if it's not left, maybe it's equal to right. Okay. In which case, let's change the output, shall we? So it's a bit boring. Um, let's make it say go left. All right. And this one will make it go right. Okay. So in this case, we can identify now left and right. Okay, in one logic, right? And else here will be reserved for all the other characters that are wrong. So we can say, please input a correct correct value, something like that. So if I were to input any kind of character here, we have now effectively avoided wrong values from destroying our program, right? So it will only work if we give it the correct values. So either it's left, okay, and then this is right, go right. So this is the part where we have to be clear with our instructions to the user. So maybe instead of give me your input, you can say, do you want to go left or right? So I'm pretty sure you guys have noticed this by now, right? Like this is beginning to look like what you see on instructions that you see online. Okay, like please input your username, please input your password, right? So basically, this is how it works underneath. Okay. So in this case, if you're asking for a username, it has to check if that username exists. If it does, then it will check if the password is correct. And then if that's correct, then it allows you in. Okay, it's just as simple as that. The logic is as simple as that. But in the case of logins, right? Uh, it's not like a different check. In this case, we're checking if the value is equals to left. If it's not, maybe it's equal to right. If it's not, then it's probably the wrong input. But if in terms of logins, we can say that the first question is, do you have a give me your username? If it exists, then it has a succeeding question, which is your password correct? So if if your logic is that you need to have a succeeding question, right? That is when you need to nest if conditions, right? So that is an if condition inside of an if condition. So for example, if username is equals to, let's just make it simple, Daniel, right? Then I will make you enter. Okay. Um, So it's gonna display something again, like pass is equals to input, like please input your password, for example, right? And then there's another if condition here. If password is equals to 1234, for example, then we can print something like that, welcome, right? Um, at the top here, we can also check you can ask the user, right? We're gonna save it to the username is equals to input, and then please input your username. Okay. Now, this is the part where indentation is very important, right? As you can see, right, the deeper it goes, the more indented your code is. Okay. We have a saying in programming where um, like if you are 3 levels deep, so this is 1 level, this is 2 levels, and if I go another tab here, this is the third level. Actually, there's too much tab here. So this is 1, this is 2, and if I were to add another tab here, right, this is the third level. It depends on the programmer really, but I don't know if this makes sense, but anything more than 3, right? It gets a lot more confusing. So usually at this point, we rethink our logic that got us this far. Like after the third one, if it reaches the fourth, there must be something wrong with our logic because it shouldn't be this deep. It should not be this complicated. So you revisit your problem and think of a different approach on how you would um go with it, right? But that's just uh, rules that some programmers follow, but actually it's not what computers follow. It's more like the complexity of it. the deeper you go, right, the harder it is for us to keep track of what needs to be true. So something like that. So if we stick to this one, so this is 2 levels deep. If we were to run this, if username, yeah, sorry. So it's double equal. Mhm. There we go. So please input your username. So if I were to say something else, it will do nothing, right? Because we have no code that um caters to wrong answers because we don't have an else statement. So we need to put an else here to show that that username does not exist. All right. So again, if I were to run this one with any other characters, it will say that username does not exist. If I were to input the correct one, right, please input your password. And then if I were to input the wrong one, we have no way um to process wrong answers because again we also don't have an else statement here, so we need to put an else here, and then we can print um let's say we're gonna print mm, let's just make a simple password incorrect, something like that. Right, so if the username is correct and then if the password is incorrect. Okay, it will say password is incorrect. Usually what goes on after this is that it repeats the whole thing, right? It's gonna say please log in again. You have how many attempts left or something. Okay. If we were to do everything correctly, or right, it will say welcome. All right. But again, this is a simplified look. Okay, this is the basic logic of how to log in. But in an actual case, there are more things in between. Like in this part, username is with Daniel, right? And then we don't actually just do it like this immediately. You go over the database, go over the database if that username exists, right? The same thing with the password. So go over the database, go over the database. There's also the step where you have to do security check. There's also the step where, let's see, your credentials, if your account can access that um, content, or maybe you're not allowed. Like for example, admin and employees, right? So admin has certain more features. Employees only has the dashboard or something like that. So yeah, that's one application of this one. Again, what we're dealing here is the simplest form, right? But in an actual uh, login system, there's a lot more things that you need to put in the middle here in order for it to work. Okay, but the process is basically the same as this one. Okay. Let's see. Multi-way if. Mm, yeah, it's basically the same thing. Compound Boolean expressions. Yeah, I forgot. You can combine these things, different control structures like for loops and ifs. You can combine if and for loop, right? So you can say you can create a for loop here, temp in range of let's say 10, right? For example, and then I want to check if temp is equal to the value of 5. I want it to print something like middle of the sequence, something like that. And then for all the other numbers, if it's not equal to 5, I don't want it to do anything. So in this case, it will only have one output, middle of the sequence, right? Because it will only be equal during temp is equal to 5. Okay, so I hope that makes sense. Um, the same thing goes for reverse. If you say like if we have a count variable, count is equals to 0, right? And then I'm actually thinking of for loop. Um, if count, yeah, I think this will work. If count, let's try this one. If count, right? Um, we're gonna create a for loop for temp in range of 10, and then just print hello 10 times. Right. So in this case, I'm using just count, right? I want to see if Python will recognize this one. Mm. Okay. So Python will recognize this one. It's equals to 0. There you go. So you need to actually indicate it. Um, in this case, I started with an if condition, and if count is equals to 0, then it will print it out like this one, 10 times. If I were to, let's say, change this one to 5, for example, it won't do anything because it will only work if it's equal to 0. Okay. So you can combine, mix and match them for loops, ifs, and any other combinations between them. All right. Okay. So if we have Boolean values, true or false, right? We also have Boolean expressions, specifically compound Boolean expressions, right? So there's just three of them. We have the and, the or, and the not. All right. So this is the truth table. Okay, we call it the truth table because these are only the values possible for those things. Okay. Now we have A and B here, and then A and B. So and is a compound expression. So what is A and B? A and B are the values, okay, for those specific conditions that you have. Okay. So these are the possible things that you can combine them with. So it's either true, 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 false, false, true, false, false, right? If you were to use the AND compound Boolean operator, right? These are the answers that you get. So if A and B is true, the answer is true for A and B. If A is true, B is false, the A and B is equals to false, right? And so on and so forth. Um, the main thing that you have to understand here is that if you are using the AND operator, okay, um, the only time that it will become true is if both A and B is equal to true, right? Now, A and B can be any kind of conditions or expressions that you might be thinking of. Like A can be, for example, let A be equal to 5 is less than 6, right? And then B is equal to what else? Let's make them both true. 7 is greater than 4. Okay, so both of them are true. And if I were to say A and B, okay, as you can see, the and here is green. So that means it is a reserved word. You can't use the word and as a variable. Okay. So if I were to run this code, it will show true. If this was if B was equals to false, like this one, it will become false. Okay. So A and B can be any kind of expression that will result into a Boolean value, as long as it is a Boolean value. No matter how complicated your expression here may be, as long as it results to either true or false, it will accept that one. Okay. So A and B is more like a placeholder for the different conditions that you have for your program. So that's how the AND works. The OR works in the opposite way. The only time that it will become false is if both conditions A and B is equal to false, right? And true, both of them is true, needs to be true in order to be true. False, both of them needs to be false in order for it to be false. Okay. Not here is basically just the opposite. So if we have something that's true, make it into false. If we have something false, make it into true. Okay. Now, if you think about it, it's actually very easy because it came from the English language, right? Um, you need to be 18 years old and over this height to enter the ride, for example. You need either a driver's license or a government ID, for example, to enter the area, right? It's basically the same as how we are using it in English, right? So it's really nothing complicated about this one. It only becomes complicated if you're using um logics with it, right? Like numbers or you're looking for specific matches, right? But basically it works the same way with how we use it in English. Okay. Um, Precedence, right? So not has a higher precedence, meaning when Python encounters the not operator, it processes that one first before going to and the or. Okay. It's the same with you remember the principle in mathematics. Um, Depending on what school you're from, it's either gonna be PEMDAS, PEMDAS, or MDAS, either of those things. So what does this one mean? Um, Multiplication, division, addition, subtraction, right? PE here is parentheses and exponents, right? So it has a order of precedence. You start with one of higher importance, right? And go down until you reach the last one, right? So the same thing goes with programming language. It has a list of precedents, right? On which one to process first than the other. So not has a higher precedence than and or. Expressions have a higher precedence than functions, right? They have to be processed first, especially if they're inside as arguments. They have to be processed first before the function is being run. So something like that. Okay. Logical operators. So we know this one, explanation, negation, comparison, not, and or. So basically everything that we have discussed earlier, right? These things are actually very easy. There's no need for us to actually discuss this. Yeah, I think that's it. So another name for and or is conjunction, disjunction for or, and then not is logical negation. Again, these names aren't used a lot. These names come up when you are dealing with them in terms of logic theory or something. I forgot the subject for that one. The specific subject for that one in college. I think it was logic theory, where you're discussing fallacies, those kinds of stuff, right? So yeah, short circuit evaluation. The name sounds complicated, but it's really simple, right? So A and B. What is the condition for and, right? Um, it only becomes true if both A and B is true, right? So it will only proceed if A is true, right? But what if A is false? So meaning if A is false, no matter the value of B, right? No matter if it's true or false, it doesn't matter because since A is false, the answer will always be false. So what Python does is that it skips processing B entirely the moment that A is false. That's why it's called short circuit, right? The same thing goes for A or B. Um, or is only false when A is equals to false, right? So the moment that A is true, right, then so is the entire expression. There's no need anymore to process what B is, right? Basically, it's just there for the programmer, right? For the context of the programmer, right? Um, but that's only for true values. If it's false, then it's still useful. So you should still indicate it there, right? Um, so that's basically it. That's what short circuit evaluation is. There's no need to get to think too much over this one. It does this one automatically. We don't have to think about this one. It's just there so that we are aware that it exists. Okay. Testing selection statements, right? You have to make sure that all the possible branches or alternatives in a selection statement are exercised. Um, yeah, like if the user answers a different value, right? Like like if you have a list of commands and then the commands are not in that list, so it had you have to one of your conditions have to handle that error. Okay. So in essence, we call that one error handling, right? Um, it's the same thing for all languages. They call it error handling. After all testing of the actions, examine all of the conditions. Yes. Test conditions that contain compound Boolean expression using data that produce all the possible combinations of values of the operands. All right. So testing inevitably comes together with programming, right? So whenever you're programming something, the next step is to test it out. So whenever you're testing your program, you're going to have to test it with all of the possible combinations. Yes, because you're going to be performing that test over and over again whenever you change something in your code. Like for example, you have a specific data set, right? And you have a specific output of that data set, right? And you're trying to make a program that uses that data set and it should produce the same output. Now, the moment that you keep on changing your program, right? You're modifying it, you're making it more efficient or something, right? The moment that one of those becomes false, right? Is an indication that something is wrong with your program, even though there is no error that is displayed. Okay. Um, Technically, that is what we call a bug, right? Because the system did not detect any error. That's why it's a bug. Um, so yeah, you need to test for all possible combinations. In fact, there is a job that is primarily focused on testing, right? So it's different from the developers, right? We have the testers and then we have the quality analysts. Okay, so there's a lot of people involved when you're programming something. Even in data science, there's a lot of testing produced because you are what? In data science, we are gonna be creating a model, right? A model of our problem, right? And in that model, it's gonna predict some things, right? Whether it will go up or down in a chart, right? Something like that. Um, so how does the model know when to go up, right? When to go down and certain values? So because we are going to be training our model, right? We're going to be training our model with data that we have collected so that it knows how to respond to those data, right? Instead of us trying to guess it, right? It's some very complicated mathematics um, that we're gonna use soon. Okay, it can predict um, where it will go using new data, right? Based on our training data. Okay, so that training data is the same as us testing it out. right? Our program, so that we can actually produce an output, right? Your output depends on how good your training data is. Similar to how AIs work nowadays, you might be thinking that it's like what it does it by itself, but behind the scenes there are humans, actual humans that train the AI. Okay, and those people are actually experts in their field. Like for example, history or mathematics or science, right? They will train the AI based on their answers. So they will prompt the AI for something, okay? Or another user like me prompts the AI with a certain question, and then it gets reviewed by that expert, okay? That expert then, okay, says that this answer is wrong. This is the correct answer. This is how you should have answered it. And AI will learn how they answered it in that way. That's how it gets intelligent, okay? Behind the scenes, there are actually real experts that train the AI. So that's how it works. This one actually, it's kind of like an illusion, right? But, with a lot of experts training the AI, it actually becomes smart enough to answer things by itself. So that's where the magic comes in. All right. Next, while loop. Let's see. We are now in the middle. Okay, and it's 2:30. All right. It's time for an exercise. All right. Let's go. Okay. I have some simple ones here. Okay. Mm, this is going to be markdown and this one. Okay, right. I had this prepared beforehand. Uh, yeah, just these two. All right. So there you go. Actually, it's too small. Let's make it bigger. Wait, bigger. Four. There we go. So write a program that classifies temperature into different categories. So hot, moderate, cold, based on the user input. All right. So as you can see, I leave it up to you guys to think of a way on how to represent this one. So what could be the user input? The user input could be in terms of degree Celsius or degree Fahrenheit, right? And then using everything that you have learned so far, the if conditions, the for loops, right? You can um actually maybe it's just the if condition, not the for loop. You can create conditions where it will respond either hot, moderate, or cold. Or you can be creative with it and make it look like, make it say something funny or whatever it is, as long as it will uh pass the same message as these things, hot, moderate, or cold. If you want to add more different temperatures or categories, then it's up to you. Okay. The main point here is that it should classify temperature. Okay. Ticket pricing. So write a program that determines the ticket price for a movie based on age. So for example, children age under 12 gets a discount, and then seniors over 65 gets a discount. So since this is a ticket price, let's say um the people that are entering, or maybe just one person, right? One at a time. That person is over 80. So the price is now what? So if the price is um 10 and then the discount is 10%, then the price is now 9. Okay, so I want to see that output that the price is now $9 or pesos. Um, so as of how to format the output, it's up to you guys. I'll leave it up to your discretion. Okay. So maybe 15 minutes is enough for this. Okay. So timer will start now. So until 2:45. Yeah, I think 2:45 is enough. Okay, you can start now. If you have any questions, I'm just right here. And after that, we're gonna solve it together if no one was able to solve it. Okay? All right. So I'll just mute myself. Let me know if you have questions.
Oh, sir, question. Yes.
Yeah.
Uh, Sorry. What is a expected an indented block after for statements?
Okay. So I think you're just missing the indentation here. So make sure that the spaces are just one tab key, right? So if it looks like this, um, what you need to do is remove all the spaces first and then add one tab key if it's one level of uh, nesting. If it's two levels, then delete out everything and then two tab keys, right? Don't use spaces. It's gonna cause errors. All right. So it's 2:45. Um, yeah, let's begin checking your work. Who wants to volunteer for exercise number one? So I'm gonna stop my screen share. Okay, who wants to volunteer for number one?
I can try, sir.
Okay, sir. The floor is yours.
Gonna share my screen.
Yep.
Do you see my screen right now, sir?
Yep. We can see it, sir.
So I've created the a function kasi classify unsquare temperature with the temp is the container for the result.
Mhm.
So I tried if the temperature is less than equal by 30, it's hot, and if is temperature is less than equal to 30 or 15, it's moderate, and the final one is it returns cold. So I tried I added some try except function for the um added functionality. So I use float because any type of format by the number, it will be accepted by accepted. So if we run, and we enter the temperature in Celsius, 25, it's moderate, then 30, that's so 15, then it's cold.
All right.
So my basis, sir, is it's around 30 degrees Celsius.
Mhm. Yeah, that's okay. Um, all right. So since you have a try-catch error, can you try inputting their strings instead of numbers? All right.
Yeah. So it will be another set of answer uh validations
Mhm.
when it comes to user input.
All right. So thank you for that answer, sir. For those who are watching, Sir Ryan's answer. So the try error there is a bit of an advanced stuff and also the function creation at the top. So what Sir did is create a function out of the exercise and then he just needs to call that function and uh, the output will appear as what you have seen, hot, moderate, or cool. And then the try catch is basically just like what it says. So try, it will try the code first. And if it will detect any error in any of those code, it will go to the accept part, all right, and then process the error there. Okay, so try catch. So it's basically the same with if and else. Okay, they just gave it a different name. So it's a bit of advanced stuff, but still the correct answer. So good job, sir. So functions and try catch, that's a bit of an advanced topic. So for those who are listening on the recording and for the others as well. Okay, thank you for that, sir. All right. So how about number two? Who wants to volunteer for number two? How about the user Alex? I think I haven't heard from
Hi.
Sir Alex. Yeah,
Hi,
sir?
sir. Sir, hi. Sorry. Can I, see the, how do you call this? The instructions again. I
Okay.
only finished the first one, sorry.
Let's see. Where is it? So here.
With children under 12, it's a discount, senior over gets, sige. Wait lang, sir. I haven't finished the whole day.
All right.
Ay, sorry, nawala ulit. If ages, the range is 65.
65 and above. So they should get a
Okay.
discount. Yeah.
Ages, yeah, children, sorry. Their age, ages, greater than, oops, the age, oops, age, age, this one, print above, oops, print less than, age, less than 12, greater than this age, above, age is less than 12.
All right. So I think we can get back
Sige,
to you later, sir, if it's still
okay,
going
sige,
so
sir.
well. All right. So let's see. Who else? How about Sir Christian? I haven't heard from you, sir.
Hi, Dion. Not yet done
Oh, you're not done. Okay.
with the number one, I think.
All right. Um, hmm, okay. How about Sir Kier? How about you, sir?
I'm not done yet. Oof.
Okay.
Sorry.
Uh,
Sorry.
that is okay. How about the others? Who else? Sir June? Sir Albert, do you have answers? Number two?
Okay, sir. May I try?
All right, Sir Albert.
Yes, may I show screen? Well, this is an experiment, and I hope I'm doing a bit risk-taking already.
That's
Okay,
okay.
yeah, I tried something like this. Where did I put it? Ah, here it is. Where is that show me screen? Then I'm sorry, these things. Oh, is that how to share this? There. I hope I could. Now, here it is.
Yeah.
Maybe this will help. There.
Okay.
Or I put int like that. Age equals like the on line 7. Enter the age.
Mhm.
So if age less than equal 12 colons and print children, then elif 12 to express 12 to 65, then 12 less than equal age less than 65. and print adult, sorry. Then else print senior citizen like that.
All right. So you got the logic correct. But what's missing is the ticket price. So you still haven't put the ticket price. Like if the price was set to $20, how much would it be if it was a child, if it was an adult, or if it was a senior citizen?
$20. Maybe this. What's the price of adult? Sorry, I haven't seen that one.
So it's up to you to decide on what the price is. Like if the price of a regular ticket is $20, so if it's a child, if the one that bought it is a uh below 12 years old, then let's say that your discount is also 10%, then it should be 18, right? And let's say that the discount for seniors is 20%, then it should be $16, right? Yeah, so those kinds of output is what's missing from your program. But the logic is already correct. So only the calculation is missing.
Okay, the calculation.
All right. So thank you for sharing your answer, sir. I noticed Sir Jude earlier was about to answer. How about you, sir?
Yes, sir. Good afternoon.
Good afternoon.
Mm, Okay, here's my screen, sir.
All right. You can start sharing.
So here's a sample on the activity number 2.
Mhm.
So if I enter, let's say for example, 10, then you are a 10-year-old and you are a child, you will get a $10 discount.
All right.
So for example, I will enter 30. You are a 30-year-old and you are an adult, you will not get a discount.
Mm-hmm.
And then for 68, you are 68 years old and you are a senior citizen, you will get $20 discount.
All right. So it's the same with Sir Albert. Your logic is there, and you have a $10 discount, but we don't actually see
The price.
the price. Yeah. So that's
Yes.
what's missing. So
Yes.
all you need to do is add a logic there where you have the original price of the ticket and then the final price depending on their age. So this
Okay.
is already correct, sir. It's the same as Sir Albert. It's only missing a few steps.
Noted,
Right.
sir. Thank you, sir.
Yep. So thank you for sharing your answer, guys. Let's see. Let me share back my screen. Okay, so it's already 3 p.m. and I think it's time for a break. Okay, let's all have some coffee and some snacks while we're at it. So I think 15 minutes is enough. So 3:15, around 3:15, right? I want you guys to be back here. And you don't have to leave the room, right? Just mute yourself and your video and just leave it there. Okay. All right. See you guys in 15. All right. So I hope everyone is back. Give me a thumbs up if you guys are here. All right. Sir Kier. All right. Two more before I proceed. All right. Sir Alex. One more. And then we can begin. Okay. I got your message, Sir Alex. So I'll try this one out later. But let's see. So I can't really copy and paste here in Zoom. So I'll just take a look if this will work. Mm, ticket, discount price, ticket price. All right, so you made your ticket price into a input int. All right. All right, so yours, sir, is that ticket price minus the discount price. So what will display is the discounted price, all right? But it's only for ages. Wait, this is for less than 12 and greater than, all right. And so you're making use of the um operator or operator. Hmm. All right, so you just made the discount for children and for the senior the same. All right, but that's okay. All right, so good job on this, sir. I think this will work as well. All right, so I think we can begin now. I think everyone is here. So let's continue with our lesson. All right. So we're done with the for loop. We're done with the if. Next is we'll go with the while loop. Right now, the while loop is basically the same with the for loop. The only difference is that the while loop is used to create loops that does not end. All right. Hence the word while. So while something is true, right? Keep on running the code. Else, the moment that it becomes false, it will then exit out of the loop and then proceed to the next line of code. So that's the while loop, right? So it's really great for things like um, it keeps on asking the same questions until you get it right. Okay, or you want it to do something until you have access to a certain feature, like for example, a login. So it will keep on asking you for your inputs until you give it one that exists in the database. Otherwise, it will just keep on giving you the same page, something like that, right? It has something called the sentinel, right? And this is basically the value that will terminate the loop and then goes out of the exit out of the loop and goes to the next line of code. Which we will see next. So this is the syntax for a while loop. So start with the while word, followed by the condition, just like with the if, right? And then a colon afterwards. Next is the sequence of statements that it will run, or the code that it will run if the condition is true. So here are some warnings. While this is useful, it may lead to infinite loop. And whenever you try to create an infinite loop, it will crash your program. And the worst case, it will crash your computer. In the very worst case, it will cost you a lot of money if it's a server-based program that you're making, right? If it's based on the server where they bill you each time you use a function or a certain or how many lines of code that you have, so they're gonna bill you on that one whenever that code is run. And then since it is an infinite loop, you can gain a very large amount of billing um in a very short amount of time. So yeah, try to avoid this one. It has happened and it will happen again, right? Especially in servers. Okay. While loop is also called the entry control loop because of the way that it looks, because it's the same format as the if. So it needs the condition to be true. That's why we have an entry control loop, right? But nobody really uses this name. Usually we just call it the while loop. Yeah. Okay, so here's an example. Mm, all right, so let's just create our own example here. So let's say that let's have a certain number, right? Like let's say we have a variable called count, right? And then that count has a certain number, 0, okay? Now we have a while loop, right? And we want to perform a loop. We want the loop to run while the count is less than or maybe equal to the number 10, for example, right? So what will we do? We want to say print uh count is less than 10, right? And then afterwards, what do we do? Well, we have to add something to count in order for it to go up, right? Because we need it to eventually stop, right? Because in this case, right now, this will be an infinite loop because count will never be greater than 10. It will never be false. This condition will never be false, right? So um you need to control the variable here in some way or another. Okay, in this case, we're just gonna add 1 to it. Okay, so as you can see, I'm using an augmented assignment here. So we're gonna add 1 to count, and then just keep on doing that until um until it reaches more than 10. Maybe we can say it like this. Let's use an F string. Count is currently count. All right, something like that. Okay, and then why is this not working? Okay, it's first. Yeah, I think there's something missing here. So if I were to run this one, you can see that it prints out from 0 up until equal to 10, right? Because that is our condition. Less than or equal to 10, all right? And as you can see, it will stop the moment that count is greater than 10. In other words, it will stop the moment that count is, how do I say this? Greater than 10, right? The moment that this expression is equal to true. Okay. Um, let's see. So this is one very simple example. Um, let's think of another example. Like, let's see, where is our username input? Yeah, let's take this one and let's put this in a while loop. While, right? I don't have a condition yet, so I'll just hmm, sorry. Okay, so mm, I think I've used too much. I'll just do it like that. Yeah, okay, I'll just leave it at that. I think this will still work. No, wait, I don't think it will. I think Python will create an error if I force that one. All right, so let's go over our program again. So while the user input, okay, at this point, all right, um, let's see. We can have a variable that is login, right, is equals to true. Okay. So while login is equals to true, right, it will keep on asking us for uh sorry, it will keep on asking us for the username and the password until we reach the point where username and password is correct. So where do we put the login is equals to false? So we'll put it here at this part. We're gonna say login at this point will be equal to false. Or basically we can just say there are two ways to do this. We can say login is equals to false, or we can say not login. So let's just use the not login for now. Let's see. Else. So if it's correct, then it will exit out. Let's see. Over here, we're gonna say uh, dashboard, for example. All right. So not login. Actually, this is not how we used to not. Usually it's inside the if. I think we'll just stick to this one. Let's stick to basics for now. And this should work. So let's try this one. Y is true, not a value. There you go. So it needs to be capital, all right? In order for you to create actual true and false values, you need to have it capitalized, right? The first letter is capital. Okay, let's run it. Okay, please input your name. Let's give it a wrong answer for now. All right. And as you can see, the username does not exist. It will ask me for another username. Okay. So I can keep on doing this and it will just keep on repeating the same thing. It's going to keep on asking me for my username until I give it the correct one, Daniel, for example. Now it's going to ask me to please input your password. So let's try this one out. If I give out the wrong password, it's going to ask me for my username again, right? So, so far so good. It works, right? So if I give it the correct username and the correct password, it will say welcome. And then after the welcome, right, it will exit out of the entire while loop, right? And then go directly to the next line of code, which is the dashboard. Okay. And this is essentially how you use the while loop. Okay. You want to use this one where you have to continuously verify something, right? Or you want a certain feature to always work unless a specific condition is um not, not true. So yeah, as you can see, we have reached the part where it says dashboard. All right. So this is a bit more complicated example than this one. Okay. Again, we were using a condition here. This is our control variable, right? I set it to true. And the moment that I set it to false here, right? So at this point, it becomes false, right? But it will still repeat the entire loop because after this line, right? This is essentially the end of the code. It goes back up to check the login value again. And since it is false, it will now exit out the loop and then goes directly to dashboard, right? So I hope that makes sense. Okay. This one is just adding all the numbers that you enter until you put a specific character that signifies it to quit. In this case, it's the not equal to space. All right, so take a look. While data is not equal to space. Okay, so in other words, until you enter the space value, um, it will not, it will not stop. So it's using the not operator here because remember the while loop works by checking the condition if it's true, right? Now, essentially, all the characters based on this logic, all the characters that you input, as long as it's not equal to space, right, needs to be true. So in other words, you're checking for a lot of characters to be true, right? This is one of those things that I mentioned earlier. Now, instead of checking for all of the characters to be true, you can just check once when it's not true, and that will serve as your next true value. So the moment that it becomes the space bar, which is the one that you don't want, right? The moment that a character is entered, that is your true condition, all right? So it's kind of reverse. Um, you're looking for the wrong one in order to have a true value here, a true condition, if I'm making sense. Okay, you're looking for the wrong one in order for it to become true, right? That's what the not operator is for. The unequal or the not operator is used for. In this case, it won't stop until you enter a space. Okay, space key and then enter, and then it will stop, right? So just like this one, 5 plus 4 plus 3, you get 12, right? This one is the same thing. It's using the count variable and it's just adding all of the numbers up. This one is using the range. The same thing with this one. It's just that this one is using the range while this one is using manual counting, right? Can be complicated to write correctly, yes. Let's see. So this is just another example. Nothing really new here. Okay. Aside from the break, all right. So this one we can discuss this. Um, there are special keywords in Python that you can use anywhere, really. Those are the break keyword and the continue keyword. All right. Later on, we're going to be learning about the return keyword, right? But let's focus first on the break and continue. Okay. So basically, these things indicate how the code, how Python should react when it encounters this code, right? So for the break, it, of course, exits out of a loop, any kind of loop. It will skip. All right. It on a skip, it will exit out. All right. If this was being run and then we have a break statement around here, it will exit the entire thing and then go directly to the next line. That's what a break statement is. Continue here, skips an iteration. Right. That's what the continue is. Return, I'll just note this one here. Return, all right, whatever comes after, right, expression, whatever comes after return is from the name itself, returns the result of the expression. I say expression, but it can be only one value, like a variable, for example, or just a value directly. To get a result. Okay, to get the result. So let's have a example of the break. Let's go back here. Okay, let's use this example. So right now, if we run this code, we have this kind of output, right? If I want it to have a break statement, let's say if count is equal to y, I want it to exit out of the loop, all right? And then I'll have another print statement here that says outside of the loop. All right. And then it will also print out the current value of count. All right. So let's try this one out. Run. And as you can see, it prints out 0 to 4, only up to 4, because we included it here in the beginning, right? So outside of the loop, it's equals to 5. Okay. We cannot see the print statement here because the print is ran first. That code is ran first before we add 1 to count and check if it's equal to 5, right? That's why we can't see the value of 5 anymore. So if you want to see the value of 5, right? The placement of your value here, the count plus 1. We have another name for something like this. We call this one the accumulator, right? And it accumulates value, right, on each iteration. It keeps on adding 1, right, from the name itself. And so just by moving that code, right, the output will be different. So take a look. It's from 0 to 4, right? If I run this code, it will now be from 0 to 5. We can now see the number 5, right? Because at the end of the line is when we will add 1 to it. And then we can still see the printed output before it checks if it's equal to 5 and then break out of the loop. All right. So yeah, you have to place this one carefully on your program. Continue. So if it was continue, it would be something like this. So if instead of break, this is continue, what will happen is that what? It will skip an iteration. So whatever this one is currently, it will skip, right? Let's see. So if count is equals to 5, it will skip. But okay, so there's a trick here. If you run this code, okay, take a look. So this is an infinite loop. So I'm just gonna stop this one, interrupt. So as you can see, this is already an infinite loop. Take a look. It keeps on giving us the value of 5, y. Okay. It's because we put the count plus 1 after we are checking it, right? So the moment that the code enters this condition, it will always skip the loop. Therefore, the count value will never be increased by 1. So that's why it will give us an infinite loop. If we put this one back here, where we add 1 to it before we actually check it, right? Then we can actually see the output. So it's from 0 to 10, and then outside of the loop is 11. All right. So it's not really reacting the way that we want. We want the number 5 to be skipped. Okay. So if we want the number 5 to be skipped, let's see. So in this case, we should print it first, right? Afterwards, we can check if it's equal to 5. If it's not, then it should continue, but we should still add 1 to it, right? Because, yeah, so we're adding 1 to it. If it's equal to 5, then it needs to skip 5 and go directly to 6. I think this is wrong. I think my logic is wrong. Okay, let me just remove this one first. All right, so what do I want again? I want it to skip if it is equal to 5, okay? So print if count is equals to 5, then I want you to continue and then go as if nothing has happened. So if nothing has happened, then the count should be outside here, right? So count is equals to 5 and then continue. The count should be before the check, but I still want to see the output. So it should be here. So as you can see, it can be a bit tricky where to place the accumulator. And it's still wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Okay, so 1, check. If we put this one inside, then before the continue, let's see. So it's 6. 6 disappears. We can't see the number 6. Why? Because we added 1 to it. Continue. All right. So maybe we can put the if at the beginning. All right. So if count is equals to 5, continue. Let's see. Continue, and then we need to add 1 to it here as well because we need it to be equal to 6 afterwards, right? And then if we want it to run normally, it should be added by 1 after the print statement. All right, so here we go. So 0, 1, 2, 3, 4, 5 is essentially skipped, and then 6, 7, 8, 9, and 10. Outside of the loop, it's currently 11 because it has to run this code one more time, and at the end, where count is equals to 10, it has to add 1 to it before this one becomes false. So this needs to be 11, right? In this case, if you want, yeah, so it doesn't really matter because it's outside of the loop. But when it is at this point, we don't really care about what the value of count is anymore. So that's okay. What matters is that when the value of 5 is reached, or the count variable, it will skip. So that's what we see here, 0, 1, 2, 3, 4, 5. So as you can see, it's a bit tricky, right? We needed two accumulators for this one for the regular process, and two if we want to skip something, right? So yeah, that's it. Knowing where to put those accumulators is a bit tricky. All right. What else? Mhm. So you can use break statements like this one, like for error messages, right? If you have an error message and you want it to exit out of the loop, then you can force it by using the break. Okay. Mm. This one here is using the not logical operator, well, while not done. So basically it reverses the value of done. So not done, so this is false, right? And as you can see here inside of the code, it changes the value of done to true. And when this is changed, um, not true will be equal to false. So it will essentially exit out of this loop. Okay. So basically you're looking for something, you're changing something to be true in order for the condition to be false. Okay. So it's you have to think in reverse in that case. So this is how you use a not actually. You put it in conditions like this one. Right. Random numbers. Okay. So this is a bit of an extra. Um, this is actually not part of control structures. It's more like additional knowledge. So we have something called modules in programming, and this is the same in all other languages. So when you say module, right? Actually, the way that I understand this is it's basically the same thing. When you say module or library or or scripts or something like that, I think they just differ in sizes and specialty. More like scripts is the smallest, next is the module, and then next is the library. Okay, so kind of like if you're trying to compare them, scripts are like um, the process of addition, and then module is like summation, and then library is like the next level, which is mathematics or something. Okay, so it's more like the level of it. Okay, so library caters more functions, a lot more functions. Okay, module can be a part of a library where it's focused only on those kinds of functions. All right. And then scripts are basically just part of the module, okay, the smallest part. So from top to bottom, it should be library, module, and scripts. That's how I understand it. But essentially they're just the same. It's just code that you put in another file, and then you can share that file to others so that they can use it, right? This is how technology is developed nowadays. This is how we share technology using programming. So another developer here works on a specific library that handles creating models in data science, right? Um, so let's say, for example, one library is pandas. We're going to be learning about pandas soon, and it's actually a very popular library used in data science to alter and change our data, right? And it has a lot of functions there that are very useful for us that makes our lives a bit easier, okay? So basically these things in general are a collection of functions. Functions that we can use, right? All we have to do is um, download that library or get a reference from it or access it from the server. You can do it like that. There are a bunch of ways to access this one, right? It's not just one way. But the easiest way that we can do it right now is the one that comes with Python, all right? And that is the random library, okay? From the name itself, it handles functions that generate random numbers from the name of it. If you want to use a library, right, you have to use the import, right, and then afterwards the name of the library. Okay, and that's it. It's as easy as that. If you want to give it an alias or a different name, you can use as, and then the name that you want, like RN, for example. Okay, so instead of typing out random later, you can just use RN. Okay, it's an alias. Let's see here. Let's go back to our previous lessons. I want to see if I gave some examples. Two objects and methods. Okay. I have one, but we haven't used that. If I remember, one of you used the round function last time, so that's actually a method, but it's just a kind of function as well. So far we haven't used anything, right? I think that's because it's on the next PowerPoint. All right. So let's discuss how to use a library. Okay. All right. Okay. So let's say that, um, did I put that here? Right, that's not here. Okay. So, um, we're gonna assume everything inside Python is an object, right? The same thing goes for libraries. So whenever you say that something is an object, right, it is a complete description of what that object is. Okay. Let's say you were to describe a car. This is my favorite analogy. Okay, the car is an object, right? Um, Objects always have two categories underneath it, properties and methods. Okay. Properties are what make that object that object. For example, uh, for the car, right? It has what that color. It's made of steel. It has a specific make, model, brand. Okay. Basically what it is. Okay, that's what a property is. Next is we have object, right? Then we have properties, and then we have methods. Okay. Now for the car, the methods are the things that the car can do. So for example, these are what? Acceleration, brakes, handbrakes, it turns, right? The things that it can do. Okay, those are the methods. And um combining those two, you can essentially describe what an object is, what the car is, right? The same thing goes for programming. So objects have properties. They also have methods. We've been using them unconsciously without being aware of it, but they are there. Okay, now we'll try to explore them a bit deeper. So random here is a library. Library is an object. Objects have properties and methods, but what we are particularly interested in are the methods for now. Okay, the methods are essentially the same as functions. I want you to think of them as functions, but they work only on that object. Okay, functions like the print, the int, the float, right? They're not attached to anything. Okay, so they work on any kind of object as well. Okay, even the wrong ones. Methods only work on a specific object. In this case, it works on the random object. Okay. So how do you know that they are methods? Okay. or properties. Okay, so in order to access those things, you use something called the dot method. Okay, where you have to follow it with a simple dot. So for example, here we have the random, right? So you're gonna say random dot, okay, and then you follow it with a method or property. If it's a property, then it's just a regular name. Okay. There are variations where some properties are looks like functions, but they are still properties. Um, so you have to read what it is first. Okay. The methods um are always going to be with open and close parentheses, just like regular functions. The difference is that it needs to be from that object. So random dot method in order to access that function. Okay. Or in this case, since we're using an alias, it's just rn. Okay. Now, if you are going to search this one, random library Python, right? So here's one. Um, Take a look. These are all the methods, as you can see here, methods available for the uh, random library. Okay. It doesn't show the properties, but it should be there somewhere if you search. So we'll just choose one that is very easy. So for example, the rand int, okay? It has a description, returns a random number between a given range, okay? So if you click on this one, you'll have some examples, I guess. So as you can see, um, so this is how you use it. Syntax, random. As you can see, random.randint, start and stop. All right, so it's that easy. So all you have to do is learn the syntax and then you can use it immediately. So rn.methods, no wait, rand int, okay. I want to generate a random integer from 10 to 100. What happened? 100. All right. So as you can see, it's 28, right? And if I keep on running this code, it will keep on generating a different number every time, hence the random integer generator, right? So it keeps on generating a random number from 10 to 100. And that's how you use a library, okay? Now you can use all the other libraries available here in Python. So it's up to you guys to explore the other things, right? We have, let's see, does it have a list here? Uh, hmm. Machine learning. Nope. What do you have here? Yeah. Libraries. Oh, here it is. So we have, so it's actually a module, not a library. All right. So, so yeah, I'm sorry for that one. But you know, in my way of thinking, I treat those things as actually the same thing because you access them in the same way. And yeah, so aside from the script, because it's just a file, you can just copy and paste the code directly. Right, so it has random module, we have request module, we have statistics, we have math, we have CMath. I'm not sure what CMath is about. It's complex numbers. All right, so that's what the C stands for. Okay. What else do we have here? We have statistics or requests. Requests, right? This is what I'm familiar with because we're gonna be using this one later. Okay. Basically, the request is used to simulate a browser, right? Python will act like it was a browser and access the internet like it was a user. So we're gonna be doing that one soon, okay? Because we're gonna be accessing and retrieving data from websites. We call that one web scraping. All right. So I hope you're excited for that one. So now that you know how to access one library, you're now open to access all kinds of libraries in Python. So you can just search it on the Google, like what names? Popular libraries in Python, right? You can just do this one. Um, Okay, so yeah, we have matplotlib, we have scipy, we have pandas, like what I said earlier, we have numpy. So there's a bunch of them, right? And you can just click one of them. Let's say, for example, matplotlib. Go directly to their website or their documentation. Okay, so this is their website, matplotlib, and then usually there should be examples, tutorials. Maybe it's in the tutorials. Plyplot, nope, nope. Quick start guide. Yeah, this is usually the one that is easiest to follow, and it tells you how to access it. So take a look, matplotlib as PLT. So matplotlib, right? This is the entire library, and underneath that one is a module. So the module is pyplot, and then that whole thing is given an alias called PLT. All right. So this is how they do it in Python. Um, So this is one example of it. So we'll be doing these things soon, and we'll be discussing how to read these things soon as well. All right. So there are some labels here, spines, axis, right? So basically, you're just reading the data, okay, and how to produce those things. All right. So right now it seems like it's very complicated, but again, if you just try to understand the syntax and the library itself, okay. So that's the thing. Whenever you're trying to learn a new library, you're gonna have to give it some time, like a few hours or maybe even days to get used to the whole thing, use it, right? Before you actually try and create something with it, right? Just like with any other things that you learn in it, if it's something new, you're gonna have to try it out for a while, right? So yeah, you're now open to all the libraries available in Python to try out for yourself. Okay. There are some instructions there on how to download it and install it on your computer. Some are, um, some can be accessed through the web, like um, you just have a link, right? And then you can put that link inside of Jupyter Notebook, and then it will be downloaded directly to your computer or something like that. So yeah, uh, what else? So I think that's it for the random int. So basically, these are just examples of how to use. So this is a guessing game, right? Just an application of a random number. So it looks kind of complicated, but you're just actually trying to guess a number. So as you can see, this is treated as while true because it wants it to keep on um, repeating the code until you what? Guess the correct answer, and guess what? There's the break statement. So even though you have created something that is an infinite loop, and as long as you have a way to break out of that loop, it's not an infinite loop. Okay. So yeah. So let's just go over this one real quick. We have two numbers, smaller number, and then a random generator between those two numbers, right? And then a count. So this is our counter on how many guesses we did. So at the beginning, it's going to add one to it. And then we're going to enter our guess. So it's going to say it's either too small or too large, right? So based on those two clues, we can guess what the number is, right? So we keep on getting closer and closer to the number until we got it right. And then it gives us how many tries it took for us to get. And then it breaks up. It's that simple, okay? It actually there's just one line here for the random int. It's just this one line, okay? Everything else we have learned already from before. Okay. Output from run. So this is just an example of the program before. All right, errors to rule out in the while loop. Okay. Incorrectly initialize loop control variable. Yes. Failure to update this variable correctly within the loop. Yep. This will create an error. Failure to test it correctly in continuation condition. So like if you let it run for a very long time. To halt that, the loop that appears to hang during testing, you can do Control C. Control C doesn't really work in Jupyter, but it works in Visual Studio if you're using Visual Studio. I don't know about the other IDEs. If you're using the browser, you can just close the browser and then load it again. So yeah, there are things you can do to stop the loop. Um, or the shell here in this case. Mm, yeah, ensure a break statement can be reached eventually. So these are just basic things that you need to remember whenever you are using a while loop. All right. So that's it for our PowerPoint. So these are just the summaries for everything that we have learned so far. Okay, so this is the last part. All right. So let's have one more exercise. And then before we proceed to the next PowerPoint. Okay. All right. So I have here, let's do something a bit difficult. Okay. And if possible, I want you guys to think about this solution. Okay. Um, there are solutions online, but exercise your brain. Okay. Programming is a skill, right? If you don't use it, well, you're gonna lose it. So, gonna have to use it. Let's see. Mark down. All right. So let's start with this exercise. 3, 1, 4. All right. So create a simple calculator. So I want you to create a calculator that allows the user to perform addition, subtraction, multiplication, and division. Only those four operations on two numbers, just two numbers. You can use a while loop to let the user perform multiple calculations. Okay. So since it's two numbers and an operation, so you're gonna have three inputs. You're gonna be asking for two numbers and the operation that it will use. So how are you gonna do this one? How are you gonna program this one? Okay, so just think about our entire lesson so far, right? What will you use, okay, to achieve this, to finish this exercise? All right. So just like earlier, I think 15 minutes is enough. Okay. You can use all the research you want as long as you can explain it in the end. That's fine. And of course, as long as you understand it. So let's see. Yeah, I think one exercise is enough. Yeah, yeah, they'll just have one. So that's it. Your timer starts now. Okay, and I'll check your work at 25 or 25. Okay, and we'll check it and then proceed to the next part. Right? So I'll be here muting my audio. Let me know if you have questions.
Hello.
Sir? Yes, sir.
Yeah, just want to confirm how the calculator will be stopped asking the numbers or all.
How can you repeat the question?
Like it seems that since this is looping, I just want to confirm how do we like end the calculator? Is there any specific like inputs that will stop the like
Okay.
calculator calculating the numbers?
So I leave it up to you, sir, on how you want it, how you want the program to stop, right? So it's up to you
Okay,
whether you want it to be a space or a specific string like quit. So it's up to you.
all right.
All right.
Thank you.
All right. So it's 425. Does anyone have an answer? So I haven't heard from Sir Ed Ryan earlier. How about you, sir?
Sir, good afternoon, sir.
No?
Uh, Ikaw mag-rate. Hello, sir. Hello.
No? Yes, we
Can you
can.
hear me, sir?
Yep.
Uh, I'm going to share my screen, sir.
Okay. So I'll stop mine.
I'm the operation of division. I just want to add some quotes here if the second number is zero, but I think I'm gonna do that later na lang.
All
So
right.
here is my code. So first, I need a function for the options. Okay.
Uh, um, it's already running. That's why.
Sorry. So again, here's the function to print different options or different operations that the user wanted.
Right.
So I use a while operation, but I set the value of the variable operation into one so that it will enter the while loop. So for the while loop, I'm just checking if the value entered by the user is between 0 and 5 because I have 5 options, 1 to 5.
Okay.
The 5 one is to quit the program. Just also um, prevent the user from entering less than 0 numbers. So when you select 2 for the subtraction, the system will require you two different numbers or two numbers. Entering the two numbers, the difference or the outcome of the operation is 2. Then it will ask again, same question for another operation. If the user entered 4, we'll go to the division operation. So for the quotient, sorry. For the quotient of 10 and 5, the answer is 2. So if the user wants to quit or to end the program, just type number 5 to quit. So that's also it.
Okay. So everything looks
That's the same.
great. Yeah. So it's a 100% on my end. So let's see. Mm, all right. Since you have a break statement, you could have I think you can remove operation equals to 1. You can remove that one. And then you can also, oh, wait. You're using operation as an input. Okay, you have another operation there inside. Yeah, you can remove that one. Operation equals to 1. And then you can also, instead of asking while operation less than 5 and operation greater than 0, you can just say while true. Because you're just gonna repeat the entire loop either way, right? Because you're gonna have to ask the user while it's inside the loop. So try running that one. Okay, and then try the other operations. One of the operations. All right, so it still works, right? Let's see, what else can we improve? Um, yeah, I think that's it. That's all that I can improve. So it's great that you have an options there, options function where it will always tell you what are the different possible things that you can type. Um, it doesn't have to be a function, but it's still good that you're using something like that. And what else? So you're using the F string, that's good. Multiple ellipse. Okay. So let's see. So there's something else that you forgot, but I think that's what the one that you stated earlier when when the user did not select any of your options. Try doing it, sir. If try running the code, try running the program and then use a operation that's not there, like 6, for example. Okay, so it's gonna ask for an operation, right? Okay, keep going. So it's not gonna do anything, right? Because you have no way to check. Right now, all you have is if operation is equal to 5. So maybe you can add another condition there when the number is not one of those options, then it should create like it should go back to the beginning and then ask the user for a different kind of input. But yeah, other than that, I think this is a good work. So yeah, a perfect score for me. So good job on this, sir. Thank you for sharing your solution.
Sir.
Okay. So I hope everyone understood his answer. Um, let's see. So it's 4:30. How about the others? Did you have a different way of answering it, or did it look somehow similar to what Sir Ed Ryan had? If it's something similar, then I think that's good. If you have something completely different, um, we'd like to see it. All right. So looks like everyone had the same solution. Let's see. Okay, let's proceed now to the next part of our discussion. All right. Which is, of course, functions. Okay, it's called functions, but this is more on the strings and text files. Okay. So in this section, we're going to examine the internal structure of a string much more closely. And we're going to extract portions of the string and we're going to call them substrings. All right. Now, we have discussed this one before that a string is a data structure because it composes what? A sequence of characters, right? And it follows a specific order. Okay. Um, we have a new function here. It's called the length function, and it returns the length or how many characters we have inside of that string. So where is my lecture notes? It disappeared. Okay. Did we have a len? Did we ever use the len? Nope, we did not use the len. All right, so let's discuss this one. The len basically, all right, counts the number of values inside of a sequence, right? That's the basic description of a len function. Whatever the sequence is, it will count how many values it has. Okay, how many in terms of strings, how many characters it has, right? So it's just very simple. Even the spaces, And even the special characters are counted as well. So if I try to use len over this string here, I'm gonna assign this one to a temp variable. Temp, right? Spelling. There you go. So there are a total of 27 characters, including the spaces and the special characters inside of it. All right. So that's basically what a len does. So it just shows us that um, we have a way to count it out. And the structure of how a string is stored is something like this. So hi there. Okay. Starting from the left to right, it's gonna be numbered from 0, 1 up until 8 because there are a total of how many characters are there? There are 9. 0 to 8. So those are 9 characters, right? 4, 5, 6, 1, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. It's just numbered from 0 to 8 because data structures always starts from 0. Okay, just like arrays. Okay. Strings starts at 0 as well. Okay. The numbers below indicates their positions in the string. Okay. This is also part of the reason why they are a sequence because they have to follow that specific position, all right, where they are assigned. Okay, if that character is assigned on that position, then they should always be in that position unless we edit it, right? So it should always be in that exact same sequence, right? So we call this one index numbers. Okay, so H is at index 0, I is at index 1, space is at index 2, and so on and so forth. So from this new thing that we've learned, basically it means that each character has a certain number associated with it, meaning we can get the number and we can also get the character from that number, right? This is the essence of a substring, okay? The way that the substring works is actually quite simple. This is the syntax. You start with the string, whether that string is an actual string or stored in a variable or returned from a function. It doesn't matter as long as the data type is a string, all right? And then the subscript operator, okay? Um, okay, so this is how it works. So let's think of a different word. Notebook. Space 2025. Something like that. All right. And how do we access it? You start with the string. So temp, right? It's stored in the temp variable. And then we proceed with open and close brackets. Afterwards, we indicate what? The syntax here is an integer expression. So basically, our index numbers. Okay. So counting it from left to right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Say I want to get the year of this string. So it's always gonna be at um, index 9. Okay. Let's say that I have this specific format for all my notebooks. So it's always gonna be at index 9. So let's just put 9 here. Okay. So as you can see, it will get me the number 2. Okay. So if I put 10 here, number 0, 10, 10, 10. Number 0, 11, number 2, and then 12, it's 5, right? So 12 is the last number, index number. If I go over that one, 13, it's gonna produce what? An index error, okay? So from the name itself, you already know what the error is, okay? So string index out of range. If this was in other IDEs, it may be displayed in a different way, but it should have roughly the same meaning, index error, all right? Okay, so it doesn't really mean anything if just one number, right? So what if we want to get a range of numbers, okay? In other words, a substring, that is a string within a string. So what I want to get is the string of the year 2025. So I'm gonna have to start at line, what number was that earlier? 9, right? All right, so starting from 9 to up until 5, so that's 12. So in order for us to do that, you're gonna use the colon. So starting from 12 up 9 until 12. Right, let's do this one. So it's not really the correct output. It's just 2002. All right. So meaning the way that this works is that it's the same with the range function where the stop the stop argument is where it will stop, but not including the stop value. So what do we do? Even though if the 13 value index number is an error, it will essentially stop there anyway. So you can just use that as well. And then it will not return an error. Okay. Instead, it will return to us the year. All right. But an easier shortcut is something like this. If you're just gonna access it from, let's say, I want to access the string, the substring from this index up until to the end. If you're gonna say up until to the end, then you can just say 9 colon. And it's the same thing. So this is actually much easier. Okay. It's like saying from 9 up until to the end. Give me the string. Okay. You can do this in an opposite way, right? So I want it to start at the beginning. So put nothing there and then colon. And then I want it to stop at 9, but I want 9 to be included. No, wait. Notebook is 9, index 9 is at 2, right? So index 8 is the space. So I want it to stop at the space. Therefore, I will get notebook. Okay. Now, counting it manually is kind of a hassle, right? So what you can do is you can use a for loop for this. For loop. You can use, I'm just gonna use X here for a variable for X in temp, right? And then let's see. So you're gonna say print and then X, right? So you get each character, but you don't get the index. All right. So how do we get the index? Well, we can have a special count variable here that you can use. So for example, like you have a count here is equals to 0, right? You can do this one. And then you can start at print X and then space and then count, right? And then you're gonna have to add 1 to count. Is count plus plus, is this gonna work here? Yeah, it doesn't work. So plus equal to 1. 1. 1. 1. Okay. So now we have a quick view of what are the index numbers associated with each character, right? We can use the for loop for this to give us a quick view. Okay, now we know that. All right, so I want to get the word notebook. Okay, so I know that I'm going to start at 0 and then I'm going to stop at 8. So I can put 8 here so to get the whole word. So this is one of those things that you can do instead of manually counting it like this, right? Instead of manually counting it, you can just use a for loop to get the view of it, right? And then you can use that one to access the substring that you want. All right. So in the future, there are going to be easier ways to actually get the index numbers. But right now, let's just stick to this one, right? Let's stick to the basics first. There are easier ways to achieve this. There are functions that can get what you want quite easily. Okay. Let's see. What else can you do with substrings? All right, yeah, we have negative numbers here. So What is it doing here? Right. So we have ways to access it using negative um negative substrings, like for example -1. Okay, so it's gonna start at the last character. Okay, but if I were to say -5 up until to the end, what would the output be? The output would be starting from this character. Okay, because how you read it is going to be the same, even though you're using a negative number. So the one on the left of the column is the starting point. The one on the right is the ending point. Okay. So the negative here just means that you're counting backwards. So counting backwards, all right, from right to left. So this is your start position, but you're still going to go from left to right when you are getting the substring. So don't get confused with the negative. Just because it's counting backwards does not mean that it will get the substring in a backwards way. Okay, it's still gonna be from left to right. You're just indicating it to count backwards. Okay. Another thing is that let's see. Mm, yeah. So this is a shortcut, by the way, that's used a lot in various problems. So if ever you want to reverse a string, right, this is one of the shortcuts that you can use. 2 colons, and then you put a -1 at the end, right? So this basically means to get the substring in reverse. So in this manner, you're actually reversing the string. So as you can see, it's in reverse. Okay, so that's just tips and tricks. What else? Mhm. So in this way, right, instead of using the count variable, it's using the range itself and using that range to access the index that acts as the index and then access the value of the um, variable using that index number. So what the output here, take a look, it's roughly the same as what we had here, right? The difference is that, again, we're using a count variable. We had to manually increase it one by one. In this case, it's using the combination of range and len, right, to indicate the sequence. And then it's going to print out index. And then, as you can see here, it's using the subscript operator to access the data and that specific index. And since the data here, the index keeps on increasing on every loop, right? We can eventually access all the characters inside of our string. Okay, so the same logic as this one is just um, different ways of achieving it. Okay, slicing for a substring. This is basically what we did. Yeah. All right. So we have another array here. Um, and then here's a very helpful tip when you are trying to search for something inside of a string, right? So in here, it has a list of files, but let's not go there yet. Let's have just a file, a regular file, all right? Let's say we have, mm, let's say we have temp is equals to, let's say this is our format. So driver's license underscore name underscore number, whatever that number is. Okay, so for example, that number. So this is my driver license number, for example. And then what you're gonna do is, mm, let's say you are trying to check if the value inside of that variable is actually a driver's license or something else, right? It could be an entirely different string. So let's say that in order for you to verify that it's a driver's license, it should always have the DRV at the beginning, right? So all the other government IDs are all unique. So none of them are repeating certain codes. Okay, in short, DRV is unique in all of the um for example, government IDs. But this is just an example, right? So in order for you to check, right, if uh this string DRV is in, using the in keyword, the temp is inside the string. The moment that this is true, then we can say this is an expression, okay? This entire thing is an expression. If the substring DRV is inside of temp, that's what it's trying to say, then it will either be true or false, okay? We can say that temp is a driver's license, something like that. Else, print um, invalid ID. Okay, so therefore, when I run this code, it will say temp is a driver's license ID. But if this is, let's say, what other licenses do we have? Boat, B-O-T, boat. All right, and then I'm gonna run it. So it's gonna say invalid ID. Okay, so this is if you want to check for a certain string, if a certain substring is inside of another string. So you're gonna use the in operator. That's what this is for. Okay, in this case, it just has a list of it just has a list of strings. All right, this is an array, and what it does is that it loops around that array and checks for each one if it has the .txt. All right, so this is useful if your program is what it's looking at your drive, right, and then you're looking for a specific file, okay, and you want to filter it out, right? So you can use this program to filter out all the things that are ending in txt, but you can just do this regularly with any other what do you call this one? Any other Explorer windows, right? Whether whatever OS you're using, and then there's a category, right? You can filter it out by application types, date modified, right? To sort it out. So it's already there. You don't have to actually do this one, but if you wanted to, you know how, right? Let's see. Mhm. All right. Um, since it's almost time, let's see. Let's record with Anonymous so that we could practice coding ourselves during our free time. Okay, Sir Albert. So previously we were supposed to um place our videos inside of the LMS. Um, unfortunately, we can't anymore. Um, due to technical difficulties with our LMS. So all we can upload here is our resources, right? For the videos. So it was it not shared by Marielle where the uploaded videos are? Were you able to view the recording from last week? No? All right. I'm gonna give her a quick follow-up to email to you guys the link because we uploaded the video in YouTube, right? So let me just show you where. So our videos here is actually unlisted. Is it here? Hmm, hold on, let me get it for you. All right. So here is our YouTube channel, and we separate this one to different batches. All right. Um, so as you can see, I already uploaded our first session from last week. And then on the LMS, we have our um, PowerPoint and the lecture notes. So you can just download this one. All right. Why can't you download this one? Why is it showing the code? All right, so I haven't actually tried this one last week. I forgot to edit it. Okay, so I'm gonna edit this one later so that it becomes downloadable. But you can just copy and paste this code actually if you know how to use this one. It will still work. But yeah, so it should be downloadable. It should be a file. And then this is our YouTube channel. You can just click on it. All the videos here are unlisted, so you can't search for this one. You have to have the link to in order to view it. All right. So yeah, I'm gonna give a follow-up to Marielle here. All right. Give me a moment. All right, so I just gave her a notification. So expect the email within the week or maybe even tomorrow. You should be able to have access to last week's session. For today, it's gonna take a while, so if I might be able to upload it maybe not tomorrow, maybe on Monday. I might be able to upload on Monday. So yeah, that's it for today, I think. Yeah, I think there's no time for an exercise anymore. So I think we'll just stop here for now. Uh, test. I'm gonna say PowerPoint. Right, let me put it here. PPT 4, slide 9. All right, this is where we ended up. Just for just for me to remember where we will continue. All right. So any questions before we end? All right, so I guess not. Okay. So have a great weekend, guys, and I'll see you next week. All right. Goodbye.
Thank you, sir.
Welcome.
Thank
Thank you,
you.
sir.